Bismillahirrahmanirrahim. Let's begin with the quote of the day. Life is like riding a bicycle. To keep your balance, you just keep moving. The topic I'll be presenting today is humidity and air velocity. I'll be giving my presentation today under the kind supervision of my most honorable, most respectable supervisor, Professor Dr. Saira Afzal. Learning outlines. Humidity and its types, absolute and specific humidity, detailed discussion on relative humidity, relationship of relative humidity with temperature, daily variations and seasonal variation, measurement of humidity, impact of humidity on human health, air velocity, recent updates, MCQs. Learning objectives. At the end of this presentation, participants will be able to describe what is humidity and its types, absolute and specific humidity, detailed discussion on relative humidity, relationship of relative humidity with temperature, daily variations and seasonal variation, measurement of humidity, impact of humidity on human health, and air velocity. Now, what is humidity? A measure of the amount of water in the air. Water is added to the air by the process of evaporation. Types of humidity: absolute, relative, specific. Absolute humidity. It is defined as the absolute humidity is expressed as grams of water vapor per cubic meter volume of air is the mass of water in the air. So the formula is mass of water vapor per volume of the air. It does not make temperature into consideration. Absolute humidity is in the atmosphere ranges from near 0 to rough 30 gram per cubic meter when the air is saturated at 30 degrees centigrade. The absolute humidity changes as air temperature or pressure changes. If the volume is not fixed, this makes it unsuitable for calculations. A specific humidity. It is the ratio of the mass of water vapor to the total mass of the moist air parcel. So the formula is mass of water vapor divided by the total mass of air. Water mass mixing ratio is the mass of water vapor compared to the mass of dry air. So the formula would be mass of water vapor divided by the mass of dry air. Relative humidity. It is the ratio of how much water vapor is in the air and how much water vapor the air cloud potentially contain at a given temperature, or it is the ratio of amount of water vapor in the air to the maximum amount of water vapor required for saturation of that particular temperature. The formula would be the partial pressure of water vapor divided by saturation vapor pressure into 100. It is normally expressed as a percentage. If there are no water vapors in the atmosphere, relative humidity is 0. If relative humidity is 25%, it means that the temperature is holding quarter of the water vapors that it can hold. If it is 50%, it means that the atmosphere is holding half of the water vapors that it can hold. If it is 100%, it means that the atmosphere is holding maximum of the water vapors that it can hold. The air is saturated and is at its dew point. Factors affecting relative humidity. Water vapor content. Relative humidity is directly proportional to water vapor content. If water vapors are increased due to the evaporation, relative humidity will also increase. Temperature. Most important factor in change of relative humidity. Relative humidity is inversely proportional to temperature. By increasing the temperature, water vapor capacity increases, or the saturation of the water pressure of the vapor pressure increases, and the result is decreased relative humidity. How temperature affects relative humidity. Warm air can hold more water vapors as than cold air. A warm air has low relative humidity than cold air. Here in this graph, you can see the relationship between the temperature with the relative humidity. Here's another graph showing the daily variation of temperature and the relative humidity. And this one shows the monthly variation of temperature and the relative humidity. Dew point. The dew point is the temperature the air needs to be cooled to at constant pressure in order to achieve a relative humidity of 100%. At this point, the air cannot hold more water in the gas form. If the air were to be cooled even more, water vapor would have to come out of the atmosphere in the liquid form, usually as fog or precipitation. Dew point is an absolute measure of how much moisture is in the air. What is the concept of dew point? Basically, it is the measurement of the dew. The dew point is the measurement of the dew point is related to the humidity. When there is more moisture in the air, the dew point is higher. The dew point is the temperature at which the water vapor is a sample of air at constant barometric pressure condenses into the liquid water at the same rate at which it evaporates. At temperature below the dew point, the rate of condensation will be greater than that of evaporation, forming more liquid water. The condensed water is called dew when it forms on a solid surface, or frost if it freezes. In the air, the condensed water is called either fog or a cloud, depending on its altitude when it forms. If the temperature is below the dew point and no dew or fog forms, the vapor is called supersaturated. This can happen if there are no enough particles in the air or to act as condensation nuclei. A high nuclei humidity, relative humidity, implies that the dew point is close to the current air temperature. A relative humidity of 100% indicates the dew point is equal to the current temperature and that the air is maximally saturated with water. When the moisture content remains constant and temperature increases, relative humidity decreases, but the dew point remains constant. Increasing the barometric pressure increases the dew point. This means that if the pressure increases, the mass of the water vapor per volume unit of air must be reduced in order to maintain the same dew point. Although weather conditions affect people differently, in general, in the spring and summer, surface dew point temperature at 16 degrees centigrade is comfortable, and dew point temperature of above 21 degrees centigrade is uncomfortable. The frost point. The frost point is similar to the dew point in that it is the temperature to which a given parcel of humid air must be cooled at constant atmospheric pressure for water vapor to be deposited on a surface as ice crystal without undergoing the liquid phase. Measurement of relative humidity. At first, we take a wet and dry bulb hygrometer. Then we take a reading of wet bulb thermometer and a reading of dry bulb thermometer. Then we find out the difference of dry and wet bulb thermometer reading. Then the relative humidity is determined from a table. Effects of humidity. Climate. The most humid climates on Earth are generally located closer to the equator near coastal regions. Some places experience extreme humidity during their rainy seasons, with warmth giving the feel of a lukewarm sauna, such as Kolkata, Chennai, Cochin in the India, the Siachen in India, and Lahore in Pakistan. Sakar city, located on the Indus River, is in Pakistan, has some of the highest and the most uncomfortable dew points in the country, frequently exceeding 30 degrees centigrade in the monsoon season. Human health. Humans can be comfortable within a wide range of humidities depending on the temperature from 30 to 70%. If the temperature outside is 23.8 degrees centigrade, humidity can make it feel warmer or cooler. A relative humidity of 0% would make it feel like it's only 20.5 degrees centigrade. On the other hand, a relative humidity of 100% would make it feel like it's 26.6 degrees centigrade. High humidity. Humans are sensitive to changes in humidity because our skin uses the air around us to get rid of moisture in the form of sweat. If the relative humidity is very high, the air is already saturated with water vapor and our sweat won't evaporate. When this happens, we feel hotter than the actual temperature. Some health risks which result from overexposure to humidity, hyperthermia, include low energy, lethargy, dehydration, fatigue, muscle cramps, heat exhaustion, fainting, heat stroke. Mold. 21% of the 21.8 million cases of asthma annually are attributable to residential dampness and mold. The humid conditions provide an excellent home for bacteria as well as mold growth. Asthma, allergy, and respiratory illness aggravate. Dust mites. Dust mites like moderate temperatures and high humidity as they absorb water from it. So areas with high humidity levels are great places for them to live. The microscopic creature can worsen allergies and asthma. Low humidity, dry skin and eczema. Itching and dryness can be caused by low humidity. Low humidity should be avoided to protect the tear film in our eyes. It can also aggravate certain skin conditions such as eczema, influenza. A significant link between low humidity and the easy spread of the influenza virus has been found. Studies found that in peak times of low absolute humidity, such as winter, when the air is dry, the transmission of the flu increases. Lip cracks, dryness of respiratory passages. Building construction. When the temperature is high and the relative humidity is low, evaporation of water is rapid, soil dries, wet clothes hung on a line or rack dry quickly, and precipitation readily evaporates from the skin. Wooden precipitation, wooden furniture can shrink, causing the paint that covers these surfaces uh, to fracture. When the temperature is low and the relative humidity is high, evaporation of water is slow. When relative humidity approaches 100%, condensation can occur on surfaces, leading to problems with mold, corrosion, decay, and the other moisture-related deterioration. Air velocity. The air velocity is measured by an instrument called the anemometer. It consists of four hemispherical cups attached to the ends of two crossed metal arms. There is a vertical spindle which is attached to the anemometer box. The velocity of wind is indicated on a counter called the cyclometer placed in the anemometer box. Wind velocities are normally recorded in an open flat country at a height of 10 meter. Velocities are made in meters per second. When the wind speed is 0.5 meter per second, described as complete calm with smoke rising vertically. When it is 3.3 meter per second, it is described as light breeze with leaves rustling. When it is 10 meter per second, it is described as strong wind with larger branches of trees moving. When it is 15 to 20 meter per second, it is called storm. When it is 25 to 30 meter per second, it is called gale, and over 30 to 50 meter per second, it is called hurricane. Cardiac thermometer is quite sensitive to slight air movements. It can record air velocities as low as 10 feet per minute. Wind direction. The wind direction is observed by an instrument called the wind vane. There is an arrow which turns freely about a vertical axis. The wind vane is erected at a height of 10 meter above ground level. If the arrow is motionless for 3 minutes, the wind is described as calm. The wind direction may also be noted by letting off bits of paper in the air, which gives the approximate direction. Directions are grouped into four main categories: north, east, south, and west, and 8 or 16 subcategories. Now it's time for recent updates. Impact of weather conditions on childhood admission for wheezy chest and bronchial asthma. Climate changes represents a possible threat to patients with bronchial asthma. The purpose of this study was to investigate an association between specific meteorological condition and the rate of hospital admission for bronchial asthma and wheezy chest. A retrospective study was conducted to observe the effects of changes in some meteorological variables on children aged 1 to 13 years with bronchial asthma and wheezy chest. Data were obtained from hospital registries from the study for the study period involving all patients admitted with the diagnosis of wheezy chest and the bronchial asthma. So the meteorological data were obtained from the Iraqi World Meteorological Organization and consisted of the mean monthly values of humidity, rain, temperature, dust, wind, and thunderstorms. The correlation between the mean monthly admissions for bronchial asthma and the changes in weather variables were investigated. The findings suggested that the changes in weather conditions, especially high relative humidity and cold weather, may trigger asthma attacks, especially in younger children, and thus protective measures are recommended for the children at risk. Fast response and flexible non-crystal based humidity sensors for monitoring human respiration and water evaporation on skin. So, according to the article, we developed a fast response and flexible nanocrystal based humidity sensor for real time monitoring of human activity, respiration, and water evaporation on the skin. So, thanks to the fast response and recovery time, the sensor can monitor human respiration and water evaporation on skin in real time. Due to the flexibility and the fast response recovery time, the sensor is promising for application in personal health monitoring as well as environmental monitoring. Now the time for the MCQs. First one, in the summer, if the air temperature was 70 Fahrenheit and the dew point was also 70, what would the relative humidity be? Now, in the winter, if the air temperature was 40 and the dew point was 40, what would the relative humidity be? A 70, summer 70%, winter 40%, summer 70%, winter 70%, C, summer 100%, winter 40%, D, summer 100%, winter 100%, E, summer 95%, winter 100%. Anyone? The answer is D. And number two, in the summer, if the air temperature was 70 and the dew point was also 70. Now, in the winter, if the air temperature was 40 Fahrenheit and the dew point was 40, in which situation would it feel more humid? A at 70 Fahrenheit dew point temperature, B at 40 Fahrenheit dew point temperature, C same in the both cases, D can be estimated, C E same in some cases.
B.
No, the answer is A at 70 Fahrenheit dew points temperature. Number three, a student is measuring the relative humidity using a dry and wet bulb hygrometer. In his all of the 10 readings, we notice the temperature of both the wet and dry bulb are 20 degrees centigrade. What does these same readings interpret about the relative humidity? A, relative humidity of 0%, B, relative humidity of 50%, C, relative humidity of 100%, error in noticing the readings, and E, no error in noticing.
B.
C, the answer is C, relative humidity of 100%. Fourth, a resident of Lahore in the month of July experiences moist and sticky body surface. Why it is so? A, high temperature and lower relative humidity. B, high temperature and high relative humidity. C, low temperature and low relative humidity. D, low temperature and high relative humidity. E, low temperature and very high relative humidity. The answer is A. Number fifth, a mother is anxious about her 5-year-old child who gets cracked lips and dry, scaly skin during winter seasons. How will you console the mother regarding the culprit of her son's condition? A, low temperature, B, low humidity, C, high temperature, D, high humidity, E, none. The answer is B. Yes, the answer is B. Sixth, dew point normally occurs when a mass of air has a relative humidity of A, 0%, B, 25%, C, 50%, D, 100%, E, 200%. The answer
C.
no, the answer is D, 100%. Seventh, the comparative relation between humidity of certain, the comparative relationship between the humidity of certain area with the maximum limit is called A, relative strength, B, relative humidity, C, ultra humidity, D, mild humidity, E, no humidity.
B.
Yes, it is B. Eighth, in morning at 6 a.m., the atmospheric temperature of city ABC is 50 degrees centigrade, and in noon, at the temperature increases to 22 degrees centigrade. What will be the effect of increasing temperature on the relative humidity? A, increased, B, decreased, C, remains constant, D, can be measured, E, none. It's B. Yes, it is B, decreased. Ninth, the most absolute measurement for moisture content in the atmosphere is A, relative humidity, B, absolute humidity, C, dew point, D, frost point, E, no humidity.
B.
It's C, dew point.
C.
What will happen if the atmospheric temperature is reduced when the atmospheric water vapor is already 100% saturated at a given place and pressure? A slight decline in humidity, B, dry weather, C, fog and rain, D, does not affect much, E, very much effective.
D.
It's C, fog and rain. Here is the key of the MCQs. References. The YouTube link is mentioned here. You can check all the videos and please like and subscribe. Thank you so much, everyone, for your time and your attention.
Thank you very much. Very nice presentation and very brilliant.